Let's work on calculations with balanced chemical equations. To explain what we're going to do here, I'm going to start with a really simple example. If we want to make a sandwich, if we take 2 pieces of bread and 1 piece of cheese, that would make a sandwich. Okay? So if I were to tell you that I have 6 pieces of bread, could you tell me, based on 6 pieces of bread, how many sandwiches would I make? I'd make 3, wouldn't I? What if I said I've got 6 pieces of bread, how many cheeses would I need so that I could use all my 6 breads? 3. Okay, what if I have 6 cheeses? How many sandwiches could I make with 6 cheeses? I could make 6 sandwiches, right? Why? Well, I'm just going to put 1 piece of cheese on each sandwich. If I have 6 cheeses, how many pieces of bread would I need? I'd need 12 breads. Okay, what are you doing to figure out those numbers? Common sense. Yeah? Okay, I mean, it just makes sense, right? A sandwich is 2 breads and a cheese. But do you guys see that you're kind of setting up a ratio? What if I had 5 pieces of bread? How many sandwiches would I make? 2.5, right? With 5 pieces of bread, I could make 2.5 sandwiches. Because you are using this relationship, you're saying 2 B's makes 1 S. So if I have 12 of these, I'm going to make 6 of these. It's a 2 to 1, and you're just dividing it. Well, why am I doing this? Because that looks a lot like a balanced chemical equation. So in a balanced chemical equation, we can still use the coefficients to set up a ratio. If we know how much of one thing we have, we can use the coefficients to figure out how much of something else we'd need, how much of something else we'd make, whatever. This one's easy, number one, because it's a sandwich and that just makes sense to us. It's also easy because it's just 2 to 1 or 1 to 2 or 1 to 1. But y'all know when you balance equations, sometimes there's like a 5 and a 3 and a 7, right? So it's not always going to be quite so straightforward. So let's apply this concept to an actual chemical equation. If I said nitrogen and hydrogen react to make ammonia, what do those coefficients mean, y'all? It means 1 nitrogen reacts with 3 hydrogens to make 2 ammonias. What are the units of those coefficients? The units of the coefficients are moles. They can never mean grams because moles is the unit we use in chemistry so that we know that we are always comparing the exact same number of particles, right? Because moles always goes back to that 6.02 times 10 to the 23rd. So if you have 1 mole of something, you've got 6.02 times 10 to the 23rd of them. The mass might be different because remember the other day when I had the copper and the chalk and the sugar and the water up here? Yeah? The masses are different, but using this ratio, let's start with 4 nitrogens. If I have 4 moles of nitrogen, how many moles of hydrogen are needed to react completely with that? Yep. How do you come up with 12? okay? I started with 1 nitrogen, and the problem's given me 4, so it's 4 times what I started with, right? So likewise, I need to multiply this one by 4. Let me show you how you're going to set that up. We have to start with what we're given, and we are given in the problem 4 moles of nitrogen. The question is asking for moles of hydrogen. So what I'm trying to do is convert moles of nitrogen to moles of hydrogen. Do you guys see that the nitrogen's got to go on the bottom? And I know moles of nitrogen goes in the denominator here because I want it to cancel out. And moles of hydrogen goes on the top because that's what the question is asking for. What I've set up right here is a conversion factor. So I need to make these equivalent to each other. How do I make them equivalent to each other, equal to each other? Well, I've got to use the numbers from this balanced equation. The balanced equation tells me 3 hydrogens reacts with 1 nitrogen. So I go and I put 3 on the hydrogen and 1 on the nitrogen. And I don't have to punch this one in my calculator because it's really straightforward. And I get, just like Austin said, that I'm going to require 12 moles of hydrogen. Okay? Now, are you always going to have nice whole numbers of moles? No. Absolutely not. We're going to have decimals, right? So let's use the same balanced equation, nitrogen and hydrogen to make ammonia. And let's make ourselves use our calculator. Let's calculate the moles of ammonia produced when 0.579 moles of hydrogen react with excess nitrogen. Any questions on that? Because that's just one step with the calculations on balanced equations. We're going to expand on that now. And then the next step in a problem like that would be to go to moles of whatever the next component is that you're asking about. And that's what I just had on the previous slide. You're going to use your coefficients. And then ultimately, we could figure out grams of that. How do I go back from moles of that one to grams? I've got to use my molar mass again, but this time I'm going to multiply by the molar mass instead of divide. Okay, let me throw an equation, a problem at you that's doing that whole process. We'll stick with the nitrogen plus hydrogen makes ammonia. Same balanced equation, okay? Let's calculate the mass of nitrogen needed to react completely with 4.12 grams of hydrogen to generate ammonia.
Would you work through this one with us and then give us one that we can do on our own?
Yes. Yeah. I've already told y'all we're gonna use the same formula, right? But can you see from the wording of that problem, do you see your chemical formula? Do you see that it tells you mass of nitrogen to react with hydrogen? Okay, so even if I hadn't already told y'all that, you would know it's this. And it says to generate ammonia. So you can get that information from the problem, but you have to go in and balance it, which we've already done. Now, where are we going to start?
Grams.
All right, you've got to start with what you're given, right? 4.12 grams of hydrogen. So, do you see, if you look at the top at my really sloppy little flowchart, I'm starting with grams. What does that problem ask for? It asks for mass of nitrogen. Starts me with grams of hydrogen, which is A, and it asks, sorry, for grams of nitrogen, which is something completely different. So do you see for this flow chart, I've got to start down there and go all the way through. What's the first step?
Grams to moles.
Grams to moles for the hydrogen. Set that up. What units go on bottom? Grams of hydrogen. What units go on the top? Moles of hydrogen. Where do I get my numbers there?
You divide by
I add up the molar mass for hydrogen, which is 2.02, isn't it? Right? Because the periodic table says one hydrogen is 1.01, but this is H2. What number goes on the top? Kind of a trick question. Do you guys see that it's 1 mole of hydrogen? Do not use your coefficients on this step. The only step you will use your coefficients on is right here, mole to mole. Because think about it, a mole of hydrogen is 2.02 grams, right? Even though the balanced equation has hydrogen with a coefficient of 3 moles of hydrogen, that's 6 grams. Right? A mole is whatever I get from the periodic table for hydrogen, which is diatomic. Okay, so right here, my grams of hydrogen is going to cancel. And I'm left with moles of hydrogen. So I'm at this point of my flow chart. Now I've got to go from here, moles of A, to moles of B. What units are going to go on the bottom for my next step of the conversion? Moles of hydrogen goes on the bottom. How do you know to put moles of hydrogen on the bottom?
We're looking for.
Well, because that's what we need to cancel. Now, what units go on the top? Moles of nitrogen, because that's what the question's asking for. What numbers go there?
1 and 3.
1 on the top, 3 on the bottom, because this is the only step where I use my coefficients. So right here, moles of hydrogen cancels, and I'm sitting at this point of my flow chart. I'm not finished yet because I know that I've got to get all the way to grams. So what's my last step? What goes on the bottom? Moles of nitrogen on the bottom. And what goes on the top? Grams of nitrogen. What numbers go there? One on the bottom. And 28.02 on the top. So moles of nitrogen is going to cancel. And I'm left with grams of nitrogen, which is what the question asked for. Calculate the mass of nitrogen. So all I have left to do is calculate it with my calculator. I got 19.0 grams.